We're going to sketch this bad mamma jamma, but we're going to do it by writing it in Vertex standard form. Okay, I know this book just calls it standard form, but I'm going to call it Vertex standard form because it does have a vertex in it clearly. This is the form we're going to write it in. We're going to write it as a times x minus h squared plus k. So, let's first change this guy into this form right here. When I do that, I'm going to write like this. I'm going to kind of like see into the future here. I'm going to need to take out that 2. And I have an x squared plus 4x and then a plus blank. And I'll explain it to you in a second. I don't want you guys to feel like you're lost right now. And I go plus 7, and I have a minus blank. If you add the blank, you must take away the blank. That way the blank doesn't change your function. All right, so what did I say? Oh, I wrote 6. Toad. All right, so I put 7 minus the blank. All right, so I'm going to group these two guys together. And I take a 2 out of this. That's how I got x squared plus 4. You guys with me? Yes, yes. Okay, now we just talked about this a lot. We're going to complete this square now. What do I have to add to this binomial right here so that it is a complete square? Quattro it is. So you take the middle term, you divide it by 2, then square it. But what are we really adding? Are we really adding a 4? No, we're really adding an 8. Now, this is for your notes. I'm going to write 2 times 4. So that you can then write 8 right above it. I just want you to know where the 8 came from. Because we had to take this 2 and multiply it times the 4 to see what we're really adding to it. So since we really added an 8, we must take away an 8 so we don't compromise the integrity of our function. Okay, let's keep going here. So now I can factor this. Because it's a perfect square, I just write x plus 2. And we also just talked about how we get that in a shortcut way. You just take the middle term and divide it by 2, and that's going to be the number that goes right there. Or you guys can do the big X and factor that bad mamma jamma, but I ain't going to do that right now. Then I have minus 1, because 7 minus 8 is 1. Look at that. Look at that. We have our function in standard vertex form. Ooh, he's so cute. All right, so what is my HK? Because this is my vertex. It is -2 and -1. I know some of you guys are like, wait, how did you get those numbers? You guys understand shifting pretty good. So let me talk shifting here. If I have a plus 2 right in there, which way is my regular x squared function going to move? If it says plus 2 right here, which way? To the left, 2. So I go 1, 2, down to -2. And then what does that -1 do? Moves it down 1. So I'm going to put my vertex point right there. Now, in order to graph the rest, I need 1 point. I need at least 1 point, just 1 point. Now, a really easy point to find would be my y-intercept, because at the y-intercept, the x equals 0. So if I plug 0 into this, that would be 0 plus 2. 2 squared would be 4. And 4 times 2 would be 8. And then minus 1, 7. So our y-intercept is 7. Now, if you looked over here and you were like, hey, this one's the same, I'm going to plug 0 into that. Good for you. If I plug 0 into that and 0 into that, it's clearly going to be 7. So if I go 2 spaces away and I have a point up there at 7, I can go 2 spaces away at -5. No, not -5. -4, and I have another point up there at 7. Do you guys remember that? Yeah. How come we can do that? That's because of this axis of symmetry right here. The axis of symmetry reflects the points from side to side. And so now we have our graph like so. Now, just for the sake of conversation, what is our axis of symmetry for this graph? X equals? -2. Now you must write x equals because it is a line. Now if I were just to look at only this right here, how would I know what my axis of symmetry is?
The inverse of H.
Your AOS axis of symmetry equals x equals h. So whatever h is, that's going to be your axis of symmetry. So whatever the x is on your vertex, that's going to be the axis of symmetry.